I'm Carly Miller at the University of Illinois, and I'd like to discuss the modes of preservation, which is the process that acts upon an organism from death to present day, or when a scientist stumbles upon the fossil. So there are very specific terms that we'd like to introduce and be familiar with when we're looking at a hand specimen, so that we can identify exactly what happened to that organism after death and how did it come to the state that it is in at the present. So the first mode of preservation is called original preservation. And what that means is that actual original material from that organism is still intact in that fossil specimen. So for example, we have an agnathan here, which is a jawless fish, which you'll learn. And you can tell that it's been well preserved. You actually still have scales that seem to be the same chemical composition that it was when it was living. And so we would call this original preservation. It actually still has scales. A few little hard parts are still intact. So original preservation, you can have soft parts if you're lucky. If it's frozen, if it's buried quickly, you might have a shoulder or a piece of meat or one of those soft parts of the organism still preserved. But more than likely, you're going to have the skeleton or a hard part that survived over geologic time. The second type of preservation is called carbonization. And that is basically when an organism has died, has been buried quickly, and usually pressurized, and basically reduced to a carbon signature, which in this case, in general, you can identify it by a black smudge. That's what we're reduced to when carbon is pressurized. It's basically just a carbon signature, and it's a black smudge. So you'll see that often with fern plants. That's a very popular example of, or a readily preserved carbonized organism is the fern plant. And so what you'll see is an imprint of that organism and a black smudge, and you can start to think, okay, I don't see any actual body parts of that organism, but I know that it was made of carbon, and I see an imprint there, and that's the mode called carbonization. The third one is called recrystallization. And the tricky part about recrystallization is that you actually have to have a little bit of knowledge about what the original composition of that organism was. And so, for example, we have a coral, and so you might say, as a savvy scientist, well, I know that corals are made of calcium carbonate, and that can form into two different minerals, aragonite and calcite, for example. And so if you know that, you can look at a specimen and you can say, well, I know what aragonite looks like, right? You do. I know what aragonite looks like, and this just doesn't quite look right. It seems to have the same chemical composition, but the mineral has shifted, or the needle shape is different. And so you can start to kind of put those things together in your mind. And what's really neat about recrystallization is it can have very specific structure. If you look at this specimen, you can see really specific septa, which is what they're called, but they look like kind of ribs radiating out from the mouth of a coral. And you can get really great kind of resolution in that fossil specimen, but it's been altered over time. So what recrystallization is you basically, so in this case, you start with calcium carbonate, the organism dies, is buried, it's infiltrated with water, and that water dissolves that mineral or that chemical composition there, but it starts to recrystallize basically right after it's been dissolved. And so it starts recrystallizing right in place where those original little nucleation points were, where those needles were. And so you get the same chemical composition, but it's been altered slightly. So it is a different form. So we call that recrystallization. So the fourth type of preservation, the fourth mode of preservation, is called replacement. And this is very similar to recrystallization, so we want to make sure that we can differentiate between the two. And again, you have to have some knowledge of that original chemical composition or texture or the characteristics of that living specimen. And so what replacement is when groundwater infiltrates a buried dead organism, and it dissolves and carries away those chemical components of either the shell or the skeleton or something like that, and it carries it away, and a completely new chemical composition infiltrates the system, carried by groundwater, and it recrystallizes or fills in that void space that organism had died in or was buried in. And so it is replaced completely with a different chemical composition. So again, you have to have some knowledge of that original organism and what it looked like and what it felt like and what it was made of when it was living, to identify that as replacement versus recrystallization versus original preservation. So we want to be careful with that, with replacement versus recrystallization. And a couple examples of replacement are molds and casts. So another great example of a replacement fossil is this brachiopod here. And why it's so great is that most people know that shells in general have a certain texture and a certain color that you're familiar with, usually kind of a white color, maybe made of aragonite or something like that, and you would be familiar with that color just in your own with your own observations. And why this is such a great sample and is such a great example of a replacement fossil is if you look at the surface really closely, you can tell that it's covered in a shiny material, a shiny mineral. And what that actually is pyrite, which is fool's gold. You might know it as fool's gold. And so you know, probably from your own experience or maybe your research or something, that shells are not made of fool's gold. And so you can start to think, well, what happened to this organism after it died, and how did it get to this state where it's covered in fool's gold? You'll start to realize that the shell wasn't originally made of that. And so you can make that connection where the organism died, meteoric water went through the system, carried away the original, maybe perhaps aragonite material, carried it away, and then brought in the components of fool's gold and precipitated it on that sort of matrix. And so there we have a great example of a replacement fossil. The next mode of preservation is called permineralization. And so usually you start with a porous part of the organism. So for example, bone is very porous on the inside. Wood is very porous on the inside. And so what happens is after burial, groundwater, again, infiltrates the system and carries in a mineral and fills in those pore spaces with a mineral. And so what happens is that that fossil actually ends up quite heavy. Sometimes you can see little crystals growing in the pores. It maybe takes on a different texture. It's shiny, it feels like a rock. And so you can start to get some information about what this mode of preservation was, and we call that permineralization, when a mineral has grown in the pore space of an original part of that organism. So the last thing we want to consider when thinking about modes of preservation is molds and casts. A mold and a cast is basically when you have no evidence or no original chemical composition left over, so no actual piece of that organism is left in this area, and you basically just have a representative of it again. And so a mold is basically a void space. So if you can think about it, if you push your foot into a big squishy piece of mud, you're going to get a void space there. And so that is a mold of your foot, and that's a type of if that were preserved, that's a type of fossil. And so if I were to then pour plaster or pour other type of mud or clay into that void space where your foot was, and that was hardened, I could take out that three-dimensional structure, and that is a cast of your foot. The cast is kind of the positive part of that process there, and the mold is the indentation, if you will, of that organism when it keeled over and died, or that part of the body that was pushed into the mud. So we want to be able to differentiate between molds and casts. And again, you can get how you identify that it's a mold or cast is that, again, it doesn't necessarily have a lot of detail in that structure, because if you think about organisms, they have little veins, they have little scales, they get very intricate in their structure, and a cast is sometimes just a squish in the mud. It's just kind of a little a print of that organism, and that's not always really detailed. So that's how you can start to clue in that that's a mold or a cast. So one of the themes that you've probably noticed when considering a mode of preservation is that I've been referring to that organism is buried. And so usually if an organism has a good chance of being fossilized for us to find later, it usually needs to be buried fairly quickly. And if not, that's going to affect the extent to which that organism is going to be fossilized. And so what you just want to remember is that burial is the first step in the process of preservation after an organism dies. So we just want to keep that in mind.